Okay, I'm going to show you how to do a titration of hydrochloric acid samples with sodium hydroxide. So what we're going to do is we're going to set up a burette, and the burette is going to be filled with some sodium hydroxide. The concentration of the sodium hydroxide is 0.113 moles per liter. And we standardized it. I standardized it a little bit later, or a little bit earlier, so I know exactly what the concentration of this sodium hydroxide is. Now we're going to use that sodium hydroxide to titrate some samples of hydrochloric acid. The goal is to figure out what the concentration of the hydrochloric acid is. In order to do that, we have to set up a burette. So I have a burette on my burette stand, or on a clamp, and so I'm going to insert a stopcock into the end. So I've got my burette set up. Now what I want to do is close the valve, and I want to rinse it out with some of our titrant, some of our sodium hydroxide. So I'll take some of the sodium hydroxide and I'll just fill it up with a few inches of sodium hydroxide in the bottom. So I'm rinsing it just in case there's something that's a contamination in here, and I want to react any of the contaminants so that it doesn't actually change our concentration. I'll empty it into the waste. And now that I've rinsed our sodium hydroxide burette, now I can fill up the rest of it. Please double check and just make sure that your stopcock is not leaking. So what I'm doing is I'm filling it up to approximately the line, and then I'm going to flush any air bubbles out, and then I can attach it to my burette stand. Now the initial concentration, or the initial volume of our burette, is 2.58 milliliters. So the initial for our first one is 2.58 milliliters. Now what we want to do is we want to add that to a sample, and we're going to choose a 10 milliliter sample. So what I'm going to do is I'm going to take a 10 milliliter aliquot, is what we call it, a 10 milliliter sample of our hydrochloric acid. We don't know what the concentration of the hydrochloric acid is. Just getting the volume correct in the pipette. So I'll add that to an Erlenmeyer flask, and the Erlenmeyer flask is what we'll hold our solution in. We'll just wait for the pipette to drain, and then we'll add some drops of bromothymol blue. Okay. So now we have our sodium hydroxide in the burette, and we've got our hydrochloric acid in the Erlenmeyer flask, and we're going to add them. But we need to figure out at what point do we need to stop, and that's why we have our bromothymol blue. Our bromothymol blue is an indicator, so I'll add 5 drops of that. Our bromothymol blue is an indicator, and we have a yellow color indicating that our solution is indeed acidic. And so what we can do, now that I have the sample set up and now that I have the initial volume recorded, in my first trial, I'm just going to figure out approximately what volume I need. So I'm swirling with my right hand, and then I'm controlling the stopcock with my left hand. And I'm adding until I get, okay, So you can tell I've got a blue color, so I shot past the color of green that I wanted. But that's okay, we just wanted to get a sense of how much volume it would require. So when I look at my burette, it's 3.61 milliliters. 3.61 milliliters. So now I can figure out the volume difference between the two, and I can see how far I need to go. Sorry, that's not 3.61. That's 5.61. Okay, good. So now I can subtract the two values, and I can figure out how much, approximately what volume, and I have 3.03 milliliters. So what I'm going to do is I'm going to take the sample that I just used, and I want to get rid of it into a waste beaker. I want to rinse out the Erlenmeyer flask to make sure that there's no acid or base left. Now I'm going to do it again, but this time I'm going to go drop by drop once I get close to 3 milliliters. So I'll pull in a sample again, 10 milliliters. I'll add the sample. When the sample is done adding, I'll add the bromothymol blue. Okay, there we go. So we're done adding the bromothymol blue. We'll just rinse down the sides of the beaker, try to get all the molecules into the bottom. We'll add about 5 drops of our bromothymol blue, so we've got our yellow color again. And this time we want to stop when it goes green. So I'm at my final volume for the first trial becomes the initial volume for the second trial, because the volume hasn't changed since I ended the last trial. So I'm starting at 5.61 milliliters now. And I want to go about, let's say, 2.5 milliliters, and maybe 2 milliliters. So I'm going to go all the way until 7.61. So I will stop at 7.61. Okay. So now that I've gone all the way up until about 7.6 or 7.7, now I'm going to go drop by drop. And it's important that you realize what color change is occurring. We're going from yellow and we want to stop at green. That's the whole point. And so let's go ahead and let's keep going. Drop by drop this time. And we want to stop when we see a green color persisting. And I added half a drop. So I just want to make sure that I wash down the sides of the container. And you can see that I have a much more green color than I did before. It's kind of going back yellow, but it is a green color that's persisting. It's definitely not the yellow that we had before. So I'll read the burette, and it's 8.36. 8.36. And now what I'm going to do, I have a good trial. So I'm going to be probably pretty happy with trial number 2. I'm going to do this 2 more times. And you can tell that I overshot the endpoint. So I'm going to have to do an extra trial. Okay, I have half a drop dangling, and I'll add it and wash it down. We'll see if that significantly changed the color. And you can tell it did significantly change the color. Oh, but we came back to a green. So I like this one a little bit better. So I'll reread it, and it's 16.70 now. So we'll do some quick math, and we'll try and figure out if any of this makes a little bit of sense. Okay, so I did the calculations for the difference in volume, so how much volume was added every single time. And you can see, hopefully you can see, that our 4th trial wasn't significantly far off. Maybe it was just, you know, that you know, half drop extra. But we're not going to include it because it turned a deep blue color. But we do have 3 trials. We do have 3 trials that we are willing to accept, okay? Trial number 1 and number 4, we're not going to accept because they turned a deep blue color instead of this kind of greenish color here. And so what we can do is we can use the average of these volumes. We can use the average of those volumes to be able to use in our stoichiometry, and that's your goal. Your goal is to perform the stoichiometry and see what is the concentration of this hydrochloric acid, okay? So 10 milliliter samples of hydrochloric acid with 0.113 moles per liter of sodium hydroxide. You can use the average volume of sodium hydroxide to calculate the concentration of hydrochloric acid. Make sure you write a complete balanced chemical reaction. Make sure you perform the stoichiometry correctly, with all of your units labeled and the substances that they belong to. And let me know if you have any questions.